Since the dawn of time, man has been interested in many different phenomena. One of these phenomena is high voltage in the form of lightning. Although we do not realize it, high voltage affects our daily lives in many ways. Almost every kilowatt we consume reaches us by high voltage paths. High voltage is also present and forms a main component in everyday usables, such as the high voltage tubes of every television set, computer screens, photocopy machines, and even the ignition systems of our motor cars. Today we will be looking at various forms of high voltage phenomena at the University of Stellenbosch's High Voltage Laboratory. We really hope you enjoy it and learn from the experience. Electrical corona discharges. For every action there is an opposite reaction, Newton's law. This demonstration of electrical discharges in the form of corona shows how the electrons, which are accelerated away from the two sharp points, creates a force strong enough to rotate the rod. Electrical discharges point to plane air gap. In this demonstration, you will see how electrical discharges in the form of corona starts as a glow, which then becomes streamers as the voltage is increased and eventually sparking. This takes place between a sharp point, which is at high voltage potential, through the air onto a metal plane, which is at ground potential. Electrical corona discharges, St. Elmo's fire. Now we will see how electrical discharges in the form of corona electrically breaks down the air over the surface of a glass plate. Sailors used to call this phenomena St. Elmo's fire, as this used to take place at the top of the masts on ships during electrical storms at sea. Lightning discharges, natural, courtesy of the Discovery DSTV channel. We will now look at how lightning works. Lightning begins when the negative charge starts zigzagging down in a fork pattern. It's called a stepped leader. As it nears the earth, it draws a streamer of positive charge out from the ground. As the leader and streamers meet, a powerful electrical current begins flowing. It creates the return stroke, an intensive wave of positive charge traveling upwards at 96,000 kilometers per second. Lightning discharges, lightning rod protected house. In this demonstration, we will see how a lightning rod protects a house from being struck by lightning coming from a charged cloud. Lightning discharges, unprotected house, no lightning rod. Now, let us remove the lightning rod and see if the house will survive lightning strikes from a charged cloud. Electrical power arcs, Jacob's ladder. The Jacob ladder gets its name from the Bible, when Jacob sees a ladder in his dream. This sparking effect was also used in many Frankenstein movie productions. Electrical power arcs, insulator flashovers. We now take a closer look at what happens on a high voltage insulator that has been coated with a saline solution. You will note how steam is formed as the electrolyte evaporates due to the joule heating on the insulator surface. High voltage engineering is a fascinating and exciting career. And forms the backbone of our world economy and comforts we know today. Without high voltage, man would still be back in the caveman days. We hope you have enjoyed your high voltage experience at the University of Stellenbosch's High Voltage Lab today.
Hey,